Okay, so now what we're going to do is going to apply equilibrium to acid-base solutions. So we talked about acids and bases in the last section of PowerPoint, and we just talked about them as being weak and strong and etc. But really what you'd like to do is have a way to quantify it, and you just don't want to say this guy's weaker than this guy. You want to know how much, okay, and we're going to be able to look at that. And a reference will be water, and we're going to talk about this property of water. The fact that water, if you add electricity to it, it actually provides a current, and it seems kind of odd since you would need to have electrolytes in water usually for that to happen. And why is this? Why? So let's talk about the property of water. Water is amphoteric, and so it's both base and acid, depending on what it reacts with. So if it's reacted with a stronger acid, it's a base, and if it's reacted with a stronger base, it becomes an acid. So it's amphoteric, so it can be acid or base. Well, it turns out it can that be both of those to itself. So some water are acids and some water are bases. Not all of them. So if you have 100 waters, not all of them split apart. Okay, very select few, maybe up on the order of 1 to 10 million. So if you have 10 million waters, you'll get this type of reaction. So if you have 10 million waters, 1 out of 10 million waters will split into an H plus OH minus. So we call it self-ionizes. Now, 1 in 10 million doesn't sound like very good odds, especially if we're playing the lottery. But if you have a mole of water, which is 10 to the 24th molecules almost, 1/10 millionth of a mole is 10 to the 17th water molecules would actually split apart. So that's a lot of waters. It's because there's so many waters. So a mole of water is approximately 18 milliliters. And so in the 18 milliliters, there are 10 to the 17th molecules of water that split apart. So what is that? 100 quadrillion water split apart. So it's a big deal, and it actually makes a difference in how water behaves, and we're going to take a look at that. And why does it give the conductivity when you add the electricity? It's because some of the water splits apart into ions, and ions can carry charge. Since it does split apart, so this is an equilibrium expression. And so what we can do is we can write it as the product over the reactant. Okay, H3O plus, hydronium, and hydroxide divided by the reactant. So it's squared because there's two of them. Okay, now one of the things about this is that this number here is huge compared to these guys here. These numbers are going to be on the order like 10 to the minus 8th, and this is 55.6 molar. So it's so huge compared to these two numbers. So what we're going to do, we're just going to move it up here and say it's a constant, and then what we're going to do is call that value, that new constant, kW. So the kW is equal to the hydronium times the hydroxide, and it's called the ion product of water. Another way to do it is that if you just look at the, instead of call it using splits, is that one acting like an acid and base. So water can self-ionize, is that you can write the equation as like this. So you'll see through these these slides is that these will be interchanged. Let me get my pointers. So you'll see that the H plus will be interchanged with the H3O plus. And this number here will be constant. All right. And so what is that constant? Well, it turns out to be 10 to the minus 4th. That's an empirical number. They had to find it. And when water is pure, it's when the amount of H plus is equal to OH minus. They're both equal to 10 to the minus 7th. And so if Kw is equal to the product of the two, then Kw is 10 to the minus 14th. And then we can look at different temperatures, which we'll just not look at right now. So water always ionizes, but it may not always be what H plus will be equal to OH minus. Depending on what substances you add to it, it may become, you may have more H plus than you do OH minus, or the other way around. But what will be constant will be these two. So if the H plus goes up, the OH minus will go down by the same amount. So if H plus goes to 10 to the minus 3rd, the OH minus will go to 10 to the minus 11th. And we'll be looking at that in a second. Okay. So the key thing is this number here, Kw, is constant. And the products will always equal 10 to the minus 14th as long as you're at 25 degrees Celsius. All right. There are what we call acidic and basic solutions. And we've talked about this in the lab a lot. And so kind of just talked about it without really explaining it. So let's go into that. So the product of H3O plus or H plus and OH minus equals Kw. And again, they may not equal each other. So that's what we want to look at now. So now if, for instance, so these numbers change. So H3O plus is an acid, or H plus, and OH minus is the base. So if we go back and look at the equation, you'll see that this is the conjugate acid and this is conjugate base. So if there's more acid than OH minus, that means the solution is acidic. If there's more OH minus than H3O plus, that solution is basic. And we'll have actually numbers to show this. Alright, so let's just do a little learning problem here. So let's say I know the pH, the H plus is 4.6 times 10 to the minus 8. What is the OH minus? Well, here we have our equation. It's at 25 degrees C. So what we do is solve for OH minus, and then solve for OH. And this should be molar here. This is molar squared. So what we have is the amount of OH is 2.2 times 10 to the minus 7th. And the H plus is 4.6 times 10 to the minus 8th. 2.2 times 10 to the minus 7th is greater than 10 to the minus 8th. Therefore, there's more base than acid. So this solution is basic. Okay. What we're going to do now is talk about this thing pH. We use it a lot in class. We've already used it in labs. But let's formalize it. What it's going to do is that when we look at the H plus concentrations, they're at very small numbers like 10 to the minus 7th and whatever. And they do change by not just by increments like 1 times 10 to the minus 3rd to 2 times 10 to the minus 3rd. They change like 10 to the minus 3rd to 10 to the minus 5th. So they move in like powers in terms of the power of tens. So what we're going to do is that really what we're going to be interested in is just the exponent of 10. So what we do is take the pH. pH is equal, P actually stands for power or exponent of hydrogen. So what you do is you take the minus log of H plus, and so what it does is just look at the exponent or the power H plus, or if you want to use the H3 plus. So if you take 10 to the minus third, if the H plus is equal to 10 to the minus third, you take the minus log of it, the pH would equal 3. And like I said, the changes in pH usually go up by powers of 10, not by like 1 or 2. Alright, we can also define this thing called POH, where it's looking at the minus log of OH minus. And you can do the same thing with the pKw, where the minus log of Kw is 14 of its pKw, and that's constant. These guys won't be constant, but this will. So if this goes up, this goes down because of this number here. Now if you want to go the other way, let's say you're given the pH, you can figure out the H plus by raising it to the 10th power. I mean 10 to the minus pH power, and same thing with the OH. Alright, so what you can do after messing around with the logarithms and so forth, you get the pH plus the POH is equal to pKw equals 14. And we can kind of tie this all together to a relationship. Is it's if you know the pH, you can figure out the H plus, okay, by taking the 10 to the pH power, or you could go the other way. Or if you have the pH, you can figure out the POH using this relationship. So this little circle here is kind of a good way to figure things out. So if you have H plus, you can figure out pH or OH, and then from either one of these two, you can figure this out. All right, so let's get more quantitative in terms of numbers. And look at what happens when you have pH. So when pH is equal, when the concentration of H plus, OH minus are equal, they're at 10 to the minus 7th. Now, if the H plus were to decrease, the pH would, let's say it decreases to, let's say it decreases at 10 to the minus 8th, the pH would be 8, which is the minus log of this. All right, and the OH would be 10 to the minus 6. So this goes down by a power of 10. This will go up by a power of 10. So this number 8 really means negative 8. This number here really means negative 6. And so negative 8, negative 6. Okay, so and vice versa here. All right, so this gives our relation. So if the pH is less than 7, that means acidic. That means there's more acid than base. There's more H plus. And same thing with basic. And we'll do some problems with these in a minute. Okay, so let's say I have this problem here. What are H plus and OH minus concentrations of a pH solution with pH of 3 solution? Okay, so what we can do is figure out the H plus, and it's simply 10 to the minus 3, and you get this. All right, what is the OH minus? Well, you could just take, so Kw equals this times this. So OH is equal to Kw divided by the H plus. All right, so in this case, there's more acid than base. So this solution would be more acidic. Notice pH is 3, and the POH would be 11. Then we do the same thing here. Figure out pH, so it's going to be 10 to the minus 4, and you solve for OH. Another thing to notice here is that when the pH 4 versus pH 3, the difference is 10, not 1, because these numbers here represent exponents. So if this was a pH of 5 and this was a pH of 3, the difference between their concentrations and H plus would be 100. Okay, so if one was pH 6 and the other one was pH 2, that'd be difference would be 10 to the 4th, or 10,000. All right, there are different ways we measure pH, and we've done all of these a little bit. The one that we like to use the most is the pH meter. But these guys are the ones that we used to use before we used pH meters, and just quickly just go through them. Indicator. So before we had meters back in the last century, last millennium, if we wanted to look at things that had pHs around 3.5, you look at you use bromothymol blue, phenol blue. But this is more of a curiosity, kind of a trivia thing these days, and it may be useful someday, but it's interesting. And here's some acidic pHs of natural things, and of course there's my favorite. Beer has a pH about 4.6, and when you make beer, you like it to be right around this range. Actually, beer is probably closer to 6, and this range is the range that you like to. I guess it's around 4.5, but 5.2 is the best range for fermentation of beer. All right, so going to do some calculations now. All right, so what I want to do is find the pH and the POH that I had in example 1. And if we found that the H plus was equal to 4.6 times 10 to the 8th, that means the OH minus is 2.2 times 10 to the minus 7th. And we get that by dividing 10 to the minus 14 by this value. All right, the pH is going to be this number, the minus log of this number, and the POH is going to be minus log of these. So it's this and this, and if you notice these two, they equal 14. All right, so let's do this one. What is the pH of a sodium hydroxide solution at 25 degrees Celsius, which the OH concentration is 0.0026 molar? Okay, so the amount of OH is 0.0026. So what you can do is find the PO. Okay, so the PO is going to be minus log, and that's 2.59. And the pH is going to be 14 minus the PO, and so you get 11.41. Okay, so when it times it says your turn, what you can do is just pause me, and you just pause the slide and do the problem on your own, and then we'll go through it. Okay, so we have apple juice with the H plus concentration is 1.7 times 10 to the minus 4th. Calculate the pH. All right, so I hope you see. You just take 10 to the minus. You just take the minus log of this. Okay, you get the minus log of 1.7 times 10 to the minus fourth, and that equals 3.76. Right, let's do another one. Okay, and again, you can pause if you want and try it on your own. But here's the acid, and what you want to do is you want to find the acid concentration, the pH, given the base concentration, 3.2 times 10 to the minus third. Right, so think about how to do it. So you can get there's two different ways you can do it. You can figure out the pOH, or you could figure out the hydronium concentration. Then from either one of those, you can find the pH. Okay. All right. So what we're going to do is use the KW relationship, and then figure out the acid concentration. So it's going to be 10 to the minus fourth divided by the base, and you get 3.1 times 10 to the minus 12 is the amount of acid. And then what you can do is take the minus log of that, and you get 11.5 pH. Okay, try it again. Try it on your own. So what is the hydroxide pH with the acid concentration 2.3 times 10 to the minus fifth? Okay, so what you do, one way you can do it is you can figure out the pH is going to equal to, should be minus log of 2.3 times 10 to the minus fifth, 4.6. And then simply what you can do is take, use KW expression, divide 10 to the minus 14th by the amount of acid, and you get 4.3 times 10 to the minus 10th. Okay, let's try another one. So if the PO, we want to know the PO and the acid concentration if the pH is 2.33. So there are two different ways you can do it. You can figure out the H3O plus concentration by raising this to 10 to the minus 2.33. Or what you can do is figure out the PO and then figure out the H3O plus from it. Okay, so let's see how you do it. So the PO is going to be 14 minus 2.33, and the acid concentration is going to be 10 times 2.33 power, and 4.7 times 10 to the minus third molar. Okay, again, what is the pH and hydronium concentration if the PO is 1.89? Right, so you can figure out the pH with the PO, and then what you could do is you could figure out the H3O plus from the pH. So pH is equal to 14 minus 1.89, 12.11, and then the H3O concentration is 10 times 10 to 12.11, which is this. So if you go back and look at the circle that I showed you, you can use that to figure out what you want. Okay, there's more than one way to do these problems. So think about when you do them. You know, if you're given pH, you can figure out hydronium concentration, or you can find pOH. So, or you can do them both. All right. So think about the problem. Is that how you want to get to wherever you want. So remember, pH is equal to the minus log of the hydronium concentration, but the hydronium concentration is going to be 10 to the minus the pH, and the same thing with the PO. So it just takes a little practice to work with these, so there you go. Let's try another one here. Given a pH of 3.76, what's the H plus? Okay, so this could be H plus or H3O plus. So this one is simple. So all you're going to do is take 10 to the minus 3.76. And you get 1.7 times 10 to the minus 4th. Okay, and that's it for this lecture. So that's the basics of basically pH and how it works. And we're going to start working more with equilibrium in the next slideshows. All right. See ya.